Okay, one moment, please. Okay, morning everyone. Welcome to this session number 427. And today I will try to understand the solution of this problem that I can solve in previous days. But well, the solution is this. The difference with the ordinal solution is that the kind complexity of this solution is linear compared with the other proposed that have leetcode that is linear square. Yeah, and for this reason, I think that the acceptance rate is very high, but well, whatever. This is the solution, and if I remember, well, one problem or one test is 01011. 01011. Let me check. 001. Oh, I forget the first zero. Okay, 0011011. And the idea is that count how many moves I need to move all the ones for in every position. For example, this one, how many moves take to move this one to this, one by one, obviously. This move to this, and this move to this. Okay, all of them in the first position, in the second, and so on. Okay, this is the deal with this problem. Now, the first approach that is have this time complexity is in essential discover. I think that is this and count how many times or how many space I need to move this to this to this. Sorry. Yeah, and next to is this with this with this, and this with this, and now is this here and here. Now is here. Now is and so on. I think that is clear. Okay. Now this is the solution that have that propose a lead code. The first is create well, the length this n it's equal 1 2 3 4 5 6. Okay, is 6. The answers, okay, I need to create an answer here. I think that at the beginning all of them are 0 because are primitives, and as a default is 0 0 0 0 0 0 0. Now we have these variables of balls to left and move to left, balls to right, and okay, I think I don't see before this solution, but I think this is for determine, for example, if I am here, how many balls are in this side and how many balls are in the right side, and how many moves. For example, here I should know how many numbers of moves I need to reach this position. Yeah, I think this is my impression, but well, let me come back to this. Now we have this 0 0 0 0. Okay, ball to left and moves to left, ball to right and moves to right. Okay, single pass to calculate the moves from the left and right. Okay, I think we can perform this operation in 2 loops only for simplify the process. The first time is left to right, yeah. In this case, is answer in the index I, it's equal, no, is plus equal moves to left. In this case, is 0. Okay, got it. Now bolts to left. Okay, it's only count how many elements I have before, yeah, meaning before meaning left, but how many bolts we have before the current position. In this case is 0 because it's the first position, and count the current the current element, yeah, but it's 0. In this case, where is 0, still in 0. Where is 1, increasing 1. And now moves to left, it's equal, plus equal, balls to left, it's equal to 0. Okay, let me put here. Balls to left and moves to left. Both are 0 in this moment, okay? Now, okay, now move to the next. The next is this is 0 and 0. Move to the next. Okay, here is different because it's 1, okay? But currently the move to left is still in 0. Move to left. It's still in 0. Yeah, bolts to left. Okay, in this case, this is updated to 1. And now this is updated to 1 because 0 plus 1 is 1. Okay, and this is still in 0 because the move to left before to this operation was 0. Okay, now here answering the index I, it's equal plus equal 0 plus move to left, that in this case is 1. Okay, now this is changing by 1. In this case doesn't increase, and move to left, it's equal 1 plus equal 1. Okay, okay. Move to left, it's equal 1. 1 plus 1, it's equal 2. Okay. Because this is, sorry, this is 1. And moves to left is 0, is 1. 1 plus equal 1. It's equal 2. Okay. Now move to the next. In this case is this. Answer it's equal move to the left, that is 2. This is updated by 2 because it's 1 and 2. Now all bolts to left increasing 1 because here appear another, and is 2 plus equal 2, it's equal 4. Okay. And now move to the next. The next is this. In this case is 4. And bolts to left, it's equal the character, in this case increasing 1, and it is 4 plus 3, it's equal 7. Okay, and that's it. Okay, let me check if it makes sense this. Left to right, in this case, for move this to the next is take only 1. For move this to this, take 2 because it's 1, 2. And for the last is 1, 2, 3, and 4 with this. Okay, got it. Now this is the okay. Now it's time to the right to left. Okay, let me change this. Now it's right to left. In this case, we start with n less 1 less I, that is 0. N is 6 less 1 less 1 less 0, it's equal 5. 0, 1, 2, 3, 4, and 5 is here. Now answer in the index, well, in this index, and I think that only reduce one. It's only for reduce. Again, I can do this in perfectly in 2 fours. Okay, in 2 fours, and no, please. Okay. And sorry. Yeah, I can perform this operation in two loops. Yeah, with the same result, with the same time complexity. In this case, reducing one all the time, and answer in the index j, it's equal move to right. Okay, let me change this by volts to right, moves to right. Now is in this position, plus equal moves to right. In this case, move to right, it's 0. Still in this order. Okay. And is 1. Okay. This is updated 0, 0. 0 plus 1, it's equal 1, and this is the same. Yeah. Because this is 1, is updated by 1, and this is 0 plus 1, it's 1. Okay. Both in this moment have 1. Now move to the next. Okay, I think that is much better right now, the sound, right? Okay, now the next is this. In this case, move to the right, it's 1. 2 plus 2 plus 1, it's equal 3. Okay, even, you know what? I will move this a little bit, and this is the result. This is 1, 2 plus 3. It's 2 plus 1, it's equal 3. And now this is 1, means that this is updated by 2. And this is 1 plus 2, it's equal 3. Okay, got it. Now, okay, whatever. Now the next that is this. That is 0. In this case is 1 plus 2, it's equal, well, in this case is 2. 1 plus 2, it's equal 3. It's 0, and in this case increase 3 plus 2, it's equal 5. Okay, 4, 5. Yeah, and move to the next, that is here. Yeah, in this case is 1. Okay, this increasing 1. Sorry, before it's 5. Here I need to put 5 because it's the nodes. It's 5. Now this is updated by 1, and now is 5 plus 1. 5 plus 3, it's equal 8 in this moment. And 0 plus 5, it's equal 5. The next that is this. In this case is move to right. That is 1, 2, is 5, is 8. Okay. Is 8. This doesn't increase, but increase here. 1, 2, sorry. 1, 2, 3. Now here is 8. And now the last is 11, because it's 5 and 5, 10 plus 1 is 11. 11. And this is still in the same, and I need to increase this into 1, 2, 3. Yeah, and we have the result 11, 8, 5, 3, 3, 4. Okay, I think that is wrong. Sorry, is this 4, 3, 4? 4, 3, 4. Why this is 2? Okay, I have a mistake here. why this is 4? The beginning is 0, and we have 1. We have 1, and this is 1. Now when I move to the next is this value here. Yeah, this increasing 1, and this is 3. Now to the next, okay, here is 3. This increasing 1, and this is, sorry. In this case is 4. Okay. Again, let me check if I understand. I will move a little bit this. Okay. The first is move to left, goes to left. The first direction is left to right. Okay, and I start here. Both have 0, 0, and 0. Now, in this case, I will change the color for this. The current position is equal move to left. In this case, is 0. Now this is updated 0 plus 0, it's equal 0. And this is 0 plus the move to left, still in 0. Okay, this is the same because it's 0. Now the next that is this. In this case, this one, or in this position, I need to set the current move to left, that is 0. Okay, this case is 0. And now this is updated. 0 plus 1 is equal 1. And here is the same. 0 plus 1 is equal 1. Okay. In this moment, we are saying that until this moment, until this moment, we are saying that the next element, in this case, this element in the left side contains 1 0 or 1 ball or whatever, and the number of moves in this direction, it's only 1. In this case, it's right because it's only this. Yeah, in one jump, I can reach this position. Yeah, this is the meaning of these variables. Okay. Now the next is this. In this case, we are sure that the number of balls in the left side before this is only 1. Okay, and the move for reach this, basically the previous cell contain the answer to the next cell, yeah, or the next slot. In this case, is 0 plus 1, it's equal 1. Move to left, 1 plus 0, it's equal 0. No. The first is update this. Number of balls in the left side, in this case, is still in 1. And now is ML, it's equal 1 plus 1. It's equal 2. Now move to the next. In this case, the next is another 1. I can put the 2 here. Now here, this is updated by 2, and now it's 2 plus 2, it's equal 4. Okay, we are saying that in this moment here in this cell, I know that I have 2 balls, and the number of moves that I need to reach this position is equal 4. Why? Because it's 1, 2, 3, and 4. Okay, and now for the last is okay, this is 4, and the number of balls is 3. In this case is 5, because it's 2. Sorry, no, is 4 plus 3, it's equal 7. Do you imagine that we have another element here? I know that I need 7 moves for move the ones. 1, 2, 3, 4, 5, 6, 7. Okay. Prev contains the answer to next slot. And is accumulate the number of balls and the number move to left 1. Here move move to left, in this case is 1. It is 1. In this case is 1 plus the previous equal 2. Now to the next, it's equal 2, and now this is 2. Okay, and in this moment I know that is this number of balls plus what happened is in this case is 2 PL, it's equal to move to left, in this case is the previous 2 plus 2, it's equal 4. Means that for reach this, for move all the ones in this side to this position is 4. 1, 2, 3, 4. Okay, I think that this is really, really brilliant. Editorial. Um, Yeah, I think that is brilliant. You will save this question. Oh, mm, okay. Now the next step is this. This case is minimum equal sum of two arrays after replacing zeros. Minimum equal sum. We are given two arrays, nums1 and nums2, consist of positive integers. You have to replace all the zeros in both arrays with strictly positive integers such that the sum of elements of both arrays be equal. Okay, return the minimum equal sum that obtain or less one if it's not possible. For example, in this case is 3, 2, 0, 1, 0, and the other is 5, 6, 5, and 0. In the first, I replace the 3, 2, 2, 1, and 4. And the sum is 5, 7, 8, 12. Replacing the 0 with the value 1. This case is 6 plus 5 is 11 plus 1 is 12. Mm. Hmm. Interesting. 3, 2, 0, 1, 0. The other is 5. Okay, the first point is that I need to, and I don't need to return the answer. Well, the array, sorry. Means that I only need to count how many numbers I have or how many zeros I have in the first array and in the second, and the total of the sum of this. In this case is 3, sorry, 3 plus 2 plus 1, it's equal 3 is 5 is 6. Okay. Now the other is 5, 6 plus 5, that it equal this. Okay, the difference between this it's equal 5. Means that I need to and this contain 1 0. Okay, this plus 1. Yeah, because we are trying to get the minimum number. Now the next, for example, this is 6, this is 5, this is 11. In this case is 11 less 6, it's equal 5. 5 plus 1, it's equal 6. I need um, reach the 6 here. And that's it. For example, here is 4. Sorry. The first is 2 plus 2, it's equal 4. And here is 1 plus 4, it's equal 5. And here I have two zeros. Okay, the difference between this, the first and the second file is 4 equal 1 plus 0, that is 1. And if the number of elements, if the number of elements here it's minor than the number of elements here, that is 2, it's not possible to apply the operation because I need to remove all the zeros. Okay. Okay, now I think that the first is transversal both arrays. Means 1. In this case, I need a counter integer. Zeros left. No. Yeah, 0, 1, that is zeros in the first array. It's equal 0 and integer long long total, it's equal 0, that's a long. In this case, total plus equal n. And in this case, if n it's equal 0, command it's equal 0, this plus, okay, and is the same with the other, but here is n2 total 1. Okay, total 1. And I will define here total 2. This is 2. Okay, total 2. It's equal to what is this? This is 2. And the first is, what is the formula? If the number of zeros is greater that we need to get the difference long if diff, that the difference diff it's equal math.ads total 1 plus total 2. In this case, I get the difference between both. In this case, for example, is 4 plus 5. It's equal in the ADS, it's equal to 1. Okay, in the first is asked if if the total of numbers Okay, I think that I can assume that these zeros are 1. For example, in this case, the first is 2, and 2 is equal 4, plus the number of 0 is 6. Okay, and the other is trying to get the minimum number that I can, or the minimum total that I can reach after replacing the zeros by 1. In this case, 6, and the other is only 5. If no. No, I think that I need to think more this question. Wow, it's very low. Yeah, because this doesn't mean strictly that is wrong, because in this case it's the same. Yeah. Well, I think that I will check in another transmission, but for today is enough. Thanks for following this transmission, and I hope see you in the next. Bye bye.